अगर तुम जाओ जमाना छोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। तुम्हें पाकर जमाने भर से रिश्ता तोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। बिना तेरे कोई दिलकश नजारा हम न देखेंगे। बिना तेरे कोई दिलकश नजारा हम न देखेंगे। तुम्हें ना हो पसंद उसको दोबारा हम न देखेंगे। तेरी सूरत ना हो जिसमें तेरी सूरत ना हो जिसमें वो शीशा तोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। तेरे दिल में रहेंगे तुझको अपना घर बना लेंगे। तेरे दिल में रहेंगे तुझको अपना घर बना लेंगे। तेरे ख्वाबों को बहनों की तरह खुद पर सजा लेंगे। कसम तेरी कसम कसम तेरी कसम तकदीर का रुख मोड़ लेंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम।
ಬೋರ್ ಹಂಡ್ರೆಡ್ ತಗೊಳ್ಳೋಣ ಬೋರ್ ಮೂಲ ತಗೊಳ್ಳೋಣ
खुदा से भी ना जो टूटे वो रिश्ता जोड़ लेंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। तुम्हें पाकर जमाने भर से रिश्ता तोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम। अगर तुम मिल जाओ जमाना छोड़ देंगे हम।
that makes learning easy for my child. Every child needs it.
Sunil Kumar, Aramo.
Namaste, sir.
Namaste. Yen based on book city dire.
Virtual.
Oh, ಏನಿಲ್ಲ ಅದು.
Invitations, minor notes, major notes, modulations, in C, in tune, intonations, roll rhythm, rhyming, percussions, past tense, chord, compositions, dance, drama, music, motivations, Alice, Michael, Madonna, America. We want to go. अरे बोलो बोलो. America. 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 America.
Oh, ನಮಸ್ಕಾರ.
Good morning, Prakash sir.
Good morning, Prakash sir. Good morning, sir.
Yes, sir. Prakash sir, namaste.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸುನಿಲ್ ಕುಮಾರ್.
ನಮಸ್ತೆ ಸರ್.
ಸುನಿಲ್ ಕುಮಾರ್ ಎರಡೆರಡರಲ್ಲಿ ಎಂಟರ್ ಆಗಿರ್ತಾರೆ. ಒಂದ್ ಮಿಸ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಕರೆಕ್ಟ್
ಇಲ್ಲ ಸರ್, ಇನ್ನೊಂದು ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಕೊಡ್ತಾ ಇದೆ.
ಓಕೆ 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 ಗುಡ್. ನೋಡಿ ಹೇಮಂತ್ ಪ್ರಭು ನಿಮ್ ಶಿಷ್ಯ.
ಅವ್ರು ಗ್ರೇಟ್ ಪರ್ಸನಾಲಿಟಿ ಕಣ್ರಿ. ಅಲ್ಲಲ್ಲ, ನಾನ್ ಸುಮ್ಮನೆ ಅವ್ರು ಹೊಗಳ್ತಾ ಇಲ್ಲ. ನನ್ನ ಬಹಳ ಇಷ್ಟಪಡೋದು, ಅವನನ್ನು ಬಹಳ ಇಷ್ಟಪಡ್ತೀನಿ. ಅದು ಯಾಕೆ ಏನೋ ಗೊತ್ತಿಲ್ಲ. ಹಾಡು
ಎಲ್ಲಾರು ಇಷ್ಟಪಡ್ತಾರ ಅವ್ರನ್ನ.
ಅಲ್ಲಲ್ಲ, ಬೇರೆಯವ್ರು ಗೊತ್ತಿಲ್ಲ.
ಬೇರೆ ನಾನೇ ಐತೀನಲ್ಲ ಎಕ್ಸಾಂಪಲ್.
ಹಾಡು ತೆಗಿಯಮ್ಮ ನೀನು. ಒಳ್ಳೆ
ತೆಗಿತೇನೆ ಸರ್. ನಮಸ್ತೆ.
ಅನಿಲ್ ಬಳಿಗೆ ಅವ್ರು ಬರೋದಿಲ್ಲ.
ಯಾಕಂತ?
ಓಕೆ ಸರ್.
ಅವರು ಏನೋ ಬಿಜಿ ಇದಾರಂತೆ.
ಸರಿ 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 ಓಕೆ.
Good morning, sir.
Good morning. How are you?
Yeah, I'm good, sir. Hope you're doing well.
Yes. From Monday, you are meeting there in the college.
Yeah, yes, sir. Sure.
Good morning, Hemant. Am I audible?
Yes, sir. Good morning, sir.
Good morning.
You're audible, sir.
Just can I check whether my PPT?
Yes, sir. Sure, sir.
Before.
Yes, sir.
Can
Slide
you see?
is visible, sir. Yes, sir.
The slides are moving, no? Or it's in one slide only?
No, no, no. It's not in slideshow mode.
It's not in slideshow.
Show mode.
1 minute, 1 minute.
Yes, it's moving, but not.
I'll do one thing.
Yes.
It's in, no?
Yes, sir.
The next slide.
I can.
See.
I can see
Now
reuse and recycle history.
photos are not seen, no?
No.
Slide movement is not possible, but this is okay.
Okay, sir. Fine.
This is photos you can see now, no?
Yes, now you're zoomed, I guess.
Yeah. And the next slide,
Yeah.
reuse and recycle.
Reuse and recycle now.
History.
Yes. History.
Yeah.
Now it is 15th slide.
Yeah, correct.
Yes, sir. Sir, if you make it to full screen mode, it is not visible, yeah?
It is not taking, the slide movement is not taking. Say, for example, if I make it full screen, the first slide you can see now, no?
Yeah, it is not in full screen mode. First slide, it seems. Sir, if you share it as entire screen.
Enter screen, stop sharing. 1 minute, I'll try that.
Yeah. Okay.
It is not taking.
If I have to click that window, sir.
Window only I clicked. I use that option.
Yeah, now it is coming. Yes, your entire screen can be seen now. Now, if you open PowerPoint from desktop. Yes, sir. Now click slideshows. Yes, now I can see full slide. Yes, second
slide, third slide.
Third, yes, sir.
Ecosystem restoration.
Yes, ecosystem restoration.
Okay, then I'll make it like this only. Yeah?
Yes, sir. Yes, sir. Okay, sir. Fine, sir.
Sunil, you start.
Okay, sir. Prakash, sir.
Okay.
Yes, sir. Good morning, all. So today we are gathered here for a webinar on advanced wastewater treatment for utility of treated wastewater for secondary purposes. So this webinar is given by Dr. B. Manoj Kumar, Professor and Head in the Department of Environmental Engineering, Sri Jayachamarajendra College of Engineering, Mysuru. So this webinar is organized jointly with ICI Mangaluru Centre and Sahyadri College of Engineering and Management, Department of Civil Engineering. So to begin with, I invite Dr. K.E. Prakash, Chairman, ICI Mangalore, to formally welcome all to this webinar. Over to you, sir.
Good morning to all of you. Am I audible? Am I audible?
Yes, yes,
Yes,
yes.
sir. Audible, sir.
A respected speaker of today's webinar, principal, HOD, faculty, a coordinator, all the faculty members and students of Sahyadri College of Engineering and Management, Mangaluru, secretary, treasurer, EC members, and all the members of ICI Mangaluru Center, invitees, participants, ladies and gentlemen. I have a great pleasure to welcome you all to this webinar on advanced wastewater treatment for utility of treated wastewater for secondary purpose, organized by ICI Mangaluru Center in association with Department of Civil Engineering, Sahyadri College of Engineering and Management, Mangaluru. Today's speaker, Dr. B. Manoj Kumar, is a professor and head, TEQIP 3, coordinator, Department of Environmental Engineering, SJCE, Mysuru. When we approached him, in spite of his busy schedule also, he accepted our invitation and now he has joined us. On behalf of all and my own behalf, I wholeheartedly welcome Dr. B. Manoj Kumar to this webinar. I welcome you, sir.
Thank you, sir. Thank you. Thank you, sir.
I extend my warm welcome to Principal Dr. Rajesh S., HOD Professor Hemanta Prabhu, Faculty Coordinator Professor Sunil Kumar, and all the faculty members and students of Sahyadri College of Engineering and Management, Mangaluru. I welcome Professor Hemanta Prabhu, Secretary, Engineer Anil Balaga, Treasurer, EC members, and all the members of ICI Mangaluru Center. I extend my warm welcome to invitees, participants, ladies and gentlemen. I welcome one and all. Thank you.
Thank you, Prakash, sir. Before going for the session, let me introduce Dr. B. Manoj Kumar. Dr. B. Manoj Kumar, presently working as professor and head in the Department of Environmental Engineering, Sri Jayachamarajendra College of Engineering, Mysuru, Karnataka. His professional experience includes 20 years of teaching with R&D and consultancy experience of 16 years. He did his BE and MTech from University of Mysuru and PhD in Indian Institute of Technology, Bombay, 2006. His professional experience includes he taught undergraduate students of environmental engineering and biotechnology, postgraduate of environmental engineering students. He involved in consultancy works and research projects taken up by the Department of Environmental Engineering. He taught MSc Environmental Science students in University of Mysuru, coordinated several refresher courses, workshops, and short-term courses, and delivered lectures for working professionals of various government organizations of different states, such departments such as PWD, CPWD, PhD, Zilla Panchayats, etc. Sir has guided more than 25 MTech theses, 15 BE projects, 2 MSc Environmental Science, 3 PhD candidates, and presently guiding 3 PhD students. Dr. Manoj Kumar has published nearly 30 research articles in national and international journals and conference proceedings. Sir has published 4 research articles in peer-reviewed international journals. Sir is also a reviewer for International Journals of Biotechnology and Bioengineering, published by John Ville and Sons. Bioresource Technology, published by Elsewhere Publications, Journal of Environment and Pollution, and for MOEF-sponsored research proposals. Doctor has given guest lecturers, resource person, and trained working professionals of various government departments in the refresher courses sponsored by Central Public Health Environmental Engineering Organization, Government of India programs, ITN Watson, ANSIRD, Amrit, Mission of MOUD, etc. He is also coordinator for 3-month short-term course in environmental engineering, sponsored by Central Public Health Environmental Engineering Organization, Government of India. Dr. Manoj served as State Committee member of Karnataka State Environmental Appraisal Committee, constituted by Ministry of Environment and Forest, Government of India. He was also a member of Karnataka Tank Conservation and Development Authority, that is KTCDA, Bangalore, member committee of experts constituted for examination of reported submitted by EMPRI on protection of Tippegundanahalli Reservoir, Bangalore, India. Sir has visited United States of America, UK, Australia, United Arab Emirates, Malaysia, Singapore, and presented research papers at International Water Association Young Researchers Conference at Cranfield University, UK. International Conference on Environmental Science and Technology held at Houston, Texas, USA. International Conference on Technologies and Strategic Management of Sustainable Biosystems at Perth, Western Australia. He was organizing committee member and chaired 2 technical sessions in the International Conference on Environmental Science and Technology held at Houston, Texas, USA. Dr. Manoj has been involved in consultancy and research projects taken by his department since 1993. Sir has completed around 20 such projects. Dr. Manoj has completed 3 major funded research projects funded by VTU, MOEF, and DST worth around 63 lakhs. With this vast experience, I welcome Dr. Manoj for the webinar Advanced Wastewater Treatment for Utility of Treated Wastewater for Secondary Purposes. Sir, this virtual platform is now open to you, sir. Over to you,
Thank
sir.
you. Thank you, Mr. Sunil. I will go to slides.
Yes, sir.
Can you see the first slide?
Yes, visible, sir. Audible and visible.
Yeah, thank you. Thank you all. Respected principal, deans, head of the Department of Civil Engineering, staff and faculty coordinators and faculty members of department, my dear students, as well as directors and EC members of Indian Concrete Institute, Mangalore, and other invitees. Good morning to all. And let me wish the World Environmental Day, which happened on 5th June, okay, this month. So the title I have taken for the presentation is Advanced Wastewater Treatment for Utility of Treated Wastewater for Secondary Purposes. With my research experience in advanced wastewater treatment and my expertise in utility of wastewater for secondary purpose, I have taken this topic, and I hope it will be helpful for you all, students as well as members of Indian Concrete Institute. Just to begin with World Environment Day, it's one of the biggest annual events organized by UN to generate awareness about the significance of nature. And it was established in 1972, which was the first day of the Stockholm Conference on the Human Environment. Every year on 5th June, the World Environmental Day is celebrated by UN, which is principal vehicle for encouraging awareness and action for the protection of the environment. This year theme is ecosystem restoration. And I will try to link this year theme with reuse and recycle of wastewater in my presentation. And this year theme says reimagine, recreate, restore in ecological restoration. Okay, and this is our movement. We cannot turn back time, but we can grow trees, green our cities, rewild our gardens, change our diets, and clean up rivers and coast. We are the generation that can make peace with nature. Let's get active and not timid. So, as per this year theme, that is ecosystem restoration. My area of expertise is on river water quality monitoring and modeling, and I have done almost all rivers in Karnataka, monitoring major rivers, including Kaveri, Netravati also, then Bhadra, Tungabhadra, Kabini, almost all rivers, Kali River. I have expertise in water quality studies, and ecosystem restoration. We can consider rivers as one of the ecosystem. And the Central Pollution Control Board has submitted a report last year, and it has submitted the report to National Green Tribunal of Government of India, and compared the quality of country's 19 major rivers which are considered as polluted. And the State Pollution Control Board and CPCB, Central Pollution Control Board, monitored such rivers and submitted the report to National Green Tribunal. And these are some of the rivers like Bias, Brahmaputra, Brahmani, Kaveri in Karnataka. Okay, so that is considered as Yamuna near New Delhi. All these rivers has been considered polluted. Okay, so there is a requirement of stopping the effluent discharge to such rivers. So whenever we go for monitoring of rivers, I have taken some photographs. These are all photographs taken by myself, and it is not from internet resources. The top photograph is from Kaveri. There you can see the fort, and there is a pipeline that is actually a tunnel for entry and coming out of soldiers during Tipu Sultan. Now that is converted to pipe outfall for wastewater discharge into Kaveri River. Just opposite this outfall, there is an intake for Mandya city, and during summer season, this wastewater might reach near that intake. That is the reason they have constructed a wall. And the bottom two figures are near Davangere. There is a halla called Betur Halla near Davangere, near Old City, and it is Old City wastewater which is running in that halla. And you can see washing activities, cloth or utensils in the same water, and this same water will reach Tungabhadra River, the right photograph, bottom right. This photograph is from Kali River, wherein a major pulp and paper industry as well as Dandeli town wastewater. The pulp and paper industry, they have effluent treatment plant. After treating their effluent, they are discharging by mixing with Dandeli town wastewater. And again, top photograph, the wastewater stream. It is not a river, it is wastewater stream entering to Kali River. Bottom two figures you can see. This is what I said, ecological restoration. When the Kali River is flowing full, how it looks. During extreme summer, when the flow is very less, it will be full of wastewater, partially treated wastewater. Okay, this is how it looks. Again, you can see nutrients presence in wastewater. That is the reason I'll make presentation on that. The nutrient removal is very important from wastewater. If it is left in the wastewater by treating only removal of BOD or COD, it causes aquatic plant growth in such rivers. Top photograph. Bottom, this is in Nanjangud. Now this is not happening. There was a textile industry, and this was irrigation channel. You can see the channel, and colored effluent is entering into the channel. Now that industry has been closed. And this is again Tungabhadra River near Harrier town, polluted by industrial effluent. You can see from bank, the wastewater is entering into the river, and river flow is very less. You can see the bottom photograph. You can see the depth of the river, bottom, okay, bottom of the river, you can see in such low flow condition, the impact on river water quality will be more. Here you can see again, this is what I said, ecological restoration, this year theme of World Environmental Day. Again, Kali River, you can see many aquatic species. Bottom left, you can see on the rock an alligator sitting on the rock, and several such alligators were sitting on the rock. When we went for Kali River monitoring, we saw such many alligators in that stretch where the effluent is entering into the river. So in extreme summer, the impact on aquatic species will also be more. And once we pollute the river by discharging wastewater, the monitoring is very, very expensive. This is how we monitor from our institute. This is in Madikeri, wherein coffee pulping wastewater is getting discharged into Kaveri stream. And we are monitoring, and it is very expensive, and we cannot monitor all the time. So basically, we have to prevent wastewater entry into the river. How wastewater entry into such rivers can be prevented? By treating the wastewater and reusing or recycling the wastewater. And several industries, they are following that. They are not letting out their effluent outside their premises. They are reusing it for various secondary purpose. That is what my presentation is. With this introduction, we will go to reuse and recycle. 80 countries and 40% of world population is facing chronic water problems, and the demand for water is doubling every 2 decades. Every 20 years, the demand is increasing. In the handbook on service level benchmarking, it is by Ministry of Urban Development, Government of India. They have defined reuse and recycling of sewage as the percentage of sewage recycled or reused after appropriate treatment. This is very important. After appropriate treatment in gardens, parks, irrigation, etc. And it is to be at least 20% to begin with. In fact, at Bangalore, many builders, they come out with proposals. They will treat the entire wastewater generated from their complexes, that will be reused. That is ZLD, okay, that they are planning, and they have shown us. I'll show one example of reuse of treated wastewater in Bangalore apartments. And in India, treated sewage is being used for a variety of applications such as farm forestry, horticulture, toilet flushing. This I was telling about Bangalore example. Industrial use as in non-human contact cooling towers. Industrial use, best example is at Bangalore ISRO Satellite Center. In fact, whatever the wastewater they are generating from their premises, they are treating, and adjacent there is NAL. They are buying that wastewater generated from NAL, treating in their premises and reusing for secondary purposes, including cooling towers. Fish culture, indirect and incidental uses. So coming to history of reuse and recycle, domestic wastewater used for irrigation by prehistoric civilization since the bronze age, that is 3200 BC. Wastewater was used for disposal, irrigation and fertilization purposes by Hellenic civilization, and later by Romans in areas surrounding cities. Whatever the city they generate the wastewater, it was used for irrigation purpose. Example is Athens and Rome. In more recent history, the sewage farms has been developed for wastewater application to the land for disposal, and that is nothing but agriculture use. In Silsia, in Scotland, in 1531 and 1650 it was practiced. In Europe and United States also sewage farms are there, and they are following for centuries. Paris is a typical example with the first sewage farms established in 1872, eventually processing wastewater of the entire Paris town. In Melbourne, Australia also in 1897, a sewage farm was established. The wastewater generated from Melbourne town was used for irrigation purpose. In USA and Europe, in 20th century also, they are reuse and recycling the wastewater for irrigation purpose. So modern sewage systems were first built in the mid-19th century because there were drawbacks in usage of wastewater for irrigation purpose. Major it is hygiene and health problems associated with irrigation farming. So modern sewage system was first built in the mid-19th century as a reaction to the exacerbation of unsanitary condition brought on by heavy industrialization and urbanization. Today, the planning of projects for the wastewater treatment and reuse of effluents is significantly increased in several countries, including India. So international organizations such as World Bank and WHO, World Health Organization, estimate that average annual increase in the reused volume of such water in USA, China, Japan, Spain, Israel, and Australia ranges up to 25. Average annual increase 25 times. Example, in USA, California, 860 million meter cube per year of treated wastewater was used in 2010, and it increased to 80% of treated wastewater discharge, that is 2470 million meter cube in 2030, that is planned to be reused in California. Coming to Indian cities wherein treated sewage is utilized for various purposes. Chandigarh is using treated sewage for horticulture needs of its green areas in the city. Delhi has put in place planned reuse of treated sewage for designated institutional centers. It is for secondary purposes only. Secondary treated sewage is purchased and treated for use in cooling tower, cooling water makeup in the industrial sector from Madras refineries in Madras, as well as GMR Vasavi power plant in Chennai, and RCF in Maharashtra. RCF in Maharashtra, they are purchasing, this is in Bombay, in Chembur it is located. They are purchasing wastewater from Mumbai Municipal Corporation, and they are purchasing the wastewater, not water. They are treating the wastewater in their premises, and they are using for manufacturing process purpose. And that they have found, there is a literature that they have found, if they buy raw water, drinking water for manufacturing purpose, it will be expensive when compared to treating wastewater by purchasing from the corporation and using it for manufacturing purposes. And more recently in IG International Airport in Delhi and Mumbai International Airport, sewage has been used. And most of the metropolitan cities like Delhi, Mumbai, Bangalore, and Chennai, it is almost compulsory that all the apartments with 20 houses, they have to treat the wastewater in their premises, and they have to reuse the treated wastewater for toilet flushing and other secondary purposes like for lawns, for maintaining greenery, for washing passages, then for washing vehicles and other purposes. So they have made it compulsory now. So major portion of the treated wastewater from high-rise apartments at major cities, it is being reused in their premises only. So government of Karnataka has also issued an official directive to take all necessary steps to ensure that only tertiary treated sewage is used for non-potable purposes like gardening, including parks, resorts, and golf courses. In fact, Bangalore Water Supply and Sewerage Board is selling the treated wastewater in tankers for many such resorts, hotels, parks, and golf courses. And Indian Railways also, they are following reuse, recycle for washing their coaches in Bangalore and Mysuru. Mysuru recently they have erected a STP, sewage treatment plant, and from whatever the wastewater generated from their premises is taken to that STP. After treating it, they are using it for washing coaches purposes. And ISRO Satellite Center, I gave this example. Coming to GMR Wasavi power plant at Chennai, this is first of its kind in Asia, commissioned as early as in 1999, wherein the raw sewage of Chennai city is treated in their plant premises to recover water of grade suitable for makeup in the cooling water, and is also further treated to recover a water of boiler grade. This is the flow sheet, how they are doing. They are purchasing, or they are using the Chennai city raw sewage. They are taking into flow equalization tank and passing through screens to remove the coarse material, and detritus to crush the inert materials like glass pieces, some seeds, whatever it might be. And then they are giving biological treatment. After biological treatment, including nitrification, that is ammonia, nitrogen will be removed from wastewater. It is sent to I-lime and two-stage recarbonation and acidification. After that, ferric chloride dosing will be done with the pressure sand filter, and it is passed through filtration, okay, and the spiral RO, and that is used as makeup water and in ion exchange for boiler water. Okay, this is reused, and this is practiced in Chennai and IG, Indira Gandhi Airport at Bangalore. This is the latest plant in India, wherein they are taking raw water and treated in reverse osmosis system. And whenever we use RO unit, there will be rejects from RO, and that is taken and mixed with the sewage from the terminal, generated from the terminal building, and that is blended, and that is RO reject and sewage will be treated in biological nitrification denitrification reactor. In the previous case in Chennai, it was only biological nitrification. Here it is denitrification also. The ammonia nitrogen present in sewage will be converted to nitrate nitrogen, and from nitrate to nitrogen gas. So there will be no nitrogen present in sewage after treatment. So this is passed through FECL to remove possible colloidal phosphorus also. All the nutrients will be removed, and finally it is passed through ultrafiltration cartridge filter for killing the bacteria. And this is what the flow sheet and how much water will be used. Sewage and rejects is taken, and from all the utilities they are taking, and they are using it for toilet flush. In new STP, 13 mld is taken, and how much it is sent through DMF with chlorine. 3 mld is used for toilet flush, and for horticulture purpose it is used for that is maintaining greenery in their premises, 5.7 mld. Likewise, this is the treatment scheme they are having: dissolved air flotation for removing oil and grease or any floating material; biological treatment wherein BOD and nitrogen parameters will be removed. They are adding ferric salt for removing phosphorus; and ultrafiltration and filters will be provided to remove suspended solids and pathogens. And finally, it is sent through RO membrane. Okay, and this is what they are getting. The raw sewage is 110 to 130 BOD milligram per liter, and treated is 8 to 10. Ammonia nitrogen, this is what I said, 45 to 53 milligram per liter. After nitrification, denitrification, it has come down to 1.5 to 3, and all the solids will be removed. And final, in the treated sewage, it is 10 to 15 milligram per liter. And this treated sewage is sent to further treatment for removal of phosphorus and ultrafiltration. Another plant is Mumbai International Airport. Here they are using sequencing batch reactor, circular sequencing batch reactor, followed by hypochlorination to remove or kill the microorganism. And then it is sent to pressure sand filtration and ultrafiltration. So it is, the treated sewage is free of color, organics and odor. And this treated sewage is used for toilet flushing. And I will show you. This is the circular SBR at Mumbai International Airport. And these two tanks, green color tanks, are filters, pressure sand filter and dual media filtration. And this is SBR effluent treated quality, it is shown. BOD has reduced from 102 to 3.4, COD from 230 to 15.26. This is one more very important thing is, whenever we use treated wastewater for secondary purpose, say for example toilet flushing for fire protection or vehicle exterior washing, this is followed at Bangalore in apartments. Okay, so what should be the quality of water, recycled water, that is given here. Say for example nitrogen, it should be 10 milligram per liter. If it is less than 10 milligram per liter, we can use it for all this secondary purpose. Nitrate nitrogen, it is 10 and 5. And fecal coliform, this is very important. It is nil except for irrigation purpose. Except for irrigation purpose. Okay. Color, it is colorless. It is given that. And TDS should be less than 2100 milligram per liter. So if we have to maintain this quality, say for example, BOD less than 10, phosphorus less than 1, nitrogen less than 10, then we have to treat it in a proper treatment system. And wastewater system history, if we look at, collection of wastewater was traced to early 1800s, and in US treatment and disposal of wastewater was traced in late 1800s. More effective wastewater treatment and management of treatment methods was done in the early 1900s. And whatever the wastewater generated from any premises, whether it is domestic or domestic, say for example in apartments or from town or from city, it can be distinguished as strong wastewater, medium wastewater and weak wastewater by characterizing its constituents in laboratory. Say for example, if BOD is 400, it is strong. BOD is 220, we will call it as medium with respect to that pollutant. If it is 110, weak. Similarly, ammonia, nitrogen 50, 25, 12. So based on its characteristics, we will distinguish it as strong, medium, and weak. And accordingly, we will treat the wastewater in a treatment plant. And we can classify the wastewater treatment methods as physical, chemical, and biological. Physical, it is unit operations. There is no process involved. Say for example, in screens, wastewater flow through the screens, and whatever the material size more than the opening size will be arrested in front of the screen. That is operation. The solids are any grit material present in wastewater. When it is sent to a tank, settling tank, it will settle to the bottom. There is no process involved. It is operation, settling operation. Whereas chemical and biological are unit processes. Some reactions will be taking place in the reactor while treating the wastewater. Physical unit operations, the units are screens, sedimentation, flotation to remove oil and grease, filtration. All these are physical unit operations. Chemical unit operations, precipitation. Say for example, if we want to remove phosphorus, we can remove the phosphorus from wastewater by precipitation. Gas transfer, adsorption, disinfection, all these are chemical unit processes wherein no microorganisms will be used for treating wastewater. Biological unit processes are one which uses microorganisms for treating the wastewater, and the conventional treatment system such as activated sludge process, trickling filter systems, and anaerobic treatment systems, already it is in place in many of the cities and apartments. Today I am going to tell you about advanced treatment system for removal of nutrients from wastewater. Activated sludge, trickling filter, or anaerobic treatment systems remove only organic carbon, that is BOD and COD, whereas nutrients will not be removed from such treatment plants. This is again aerobic suspended growth process, wherein nitrification process where ammonia nitrogen will be converted to nitrate, aerated lagoons, aerobic digestion process, oxidation ponds. So if we look at history, activated sludge process is the oldest biological treatment system developed in England in 1914, wherein active mass of microorganisms will be grown in the tank, and this oxidizes the organic matter present in wastewater by utilizing the oxygen supplied externally. So aerobic environment in reactor is achieved by use of diffused or mechanical aeration. And once oxidation takes place, that is the microorganisms get oxygen as well as food in the form of organic matter, it starts multiplying. And once it starts multiplying, the new microorganisms will be called as activated sludge. The new microorganisms or cells are called as activated sludge. And I will not go into details of ASP and its modification, design parameters, and we have to maintain MLSS, mixed liquor suspended solids. Why it is called as mixed liquor is the new microorganisms grown from aeration tank is made to settle in secondary settling tank, and that is called as activated sludge, and it is recycled back to aeration tank wherein the fresh wastewater is entering. So when fresh wastewater mixes with activated sludge, it is called as mixed liquor suspended solids. So this is the aeration tank at the Bangalore, KC Valley, Koramangala Chelgatta Valley treatment plant. It is one of the oldest treatment plant at Bangalore, wherein mechanical aerators have been provided to aerate wastewater. So other attached growth, these are all suspended growth, trickling filter, roughing filter, rotating biological contactor, and fixed bed nitrification reactor. All this are used. And this RBC, rotating biological contactor, you can see at ISRO Satellite Center at Bangalore. And it was installed long back. It is in 1998-99, I think. It was put into operation, rotating biological contactor. And trickling filter is another attached growth system. And this is the design information. This photograph is a trickling filter. When I visited Cranfield University at UK for a conference, this facility was created in university premises, Cranfield University premises. They have trickling filters. It is biological treatment, and this treated wastewater is given for adjacent lands for irrigation purpose. You can see the adjacent lands for irrigation purpose. This is the filter media close-up view. You can see the filter media. And this plant growth, green growth, which is occurring on the filter bed is due to sunlight as well as the nutrients present in wastewater, which encourages such growth. So the above conventional treatment systems which I showed, trickling filter or activated sludge process or anaerobic treatment, whatever it might be, it removes only organic carbon and partial nitrification takes place. Only 40% nitrification takes place. Nowadays, importance is given for nutrient removal systems. If nutrients are not removed from wastewater, the problems of aquatic plants growth in water, you can observe in the following photographs, that will be there. In all the three photographs, you can see aquatic plant growth. It is aesthetic nuisance. So domestic wastewater contains organic carbon in the form of BOD and COD, nitrogen in the form of ammonia, nitrogen, and phosphorus. Ammonia, nitrogen, and nitrate nitrogen, and phosphorus as orthophosphate. And all these three has to be removed from wastewater. And if these nutrients are not removed and discharged into lakes or surface water body, it causes eutrophication. So there are several physico-chemical treatment methods for phosphorus, but the only problem in physico-chemical treatment is it will generate chemical sludge, because we are using chemical for precipitating out nutrients, and this is uneconomical, and sludge disposal will be problem. The biological processes are claimed to be effective and economical, and we can remove the phosphorus from such system. And there are many continuous processes like anaerobic oxic, anoxic, anaerobic oxic, Baden-Foe, University of Cape Town, and VIP process. These are all conventional process. And for biological nutrient removal, both anaerobic and aerobic conditions are required. For biological nutrient removal, both anaerobic and aerobic, that is microorganisms surviving under anaerobic condition without oxygen, and microorganisms surviving under oxic condition with oxygen, that is required. This SBR sequencing batch reactor I was telling about, Mumbai International Airport, where they have provided this treatment system. And in almost Bangalore, almost all apartments, even in Art of Living, Ravi Shankar Guruji's Art of Living, they have put a sequencing batch reactor for treating wastewater. And this is batch reactor, whereas the previous ones we discussed is continuous flow reactors. And here, since it is batch reactor, in the tank, we fill the tank, and we provide anaerobic phase. We will not supply oxygen to the system, and after certain duration, again oxygen will be supplied, and it will be stopped, and the solids will be allowed to settle, and 50% of treated wastewater on the top will be taken out. That is called as decantation. This is called as sequencing batch reactor, and there is high possibility of removing carbon, nitrogen, and phosphorus. Organic carbon, anyhow, anaerobic or aerobic condition, it will be removed. Ammonia, nitrogen in aerobic condition gets converted to nitrate, and nitrate, nitrogen under anoxic, that is anaerobic condition, it will be removed. So nitrate partial removal will be there. And for phosphorus removal, both anaerobic and aerobic is required, and I'll explain. This is how the phosphorus removal takes place from wastewater, and it is by a process called as enhanced biological phosphorus removal. In the SBR, once the tank is filled with raw wastewater, initially the anaerobic phase will be provided. This one is the phosphorus accumulating organism, and it has polyphosphate inside the cell, and wastewater containing phosphorus, when it is filled into the reactor, whatever the polyphosphate stored in the reactor, in the microorganism will come out of the microorganism and enters the wastewater, and the wastewater phosphorus concentration increases. In the anaerobic phase, phosphorus release occurs. You can see when wastewater is put into the reactor containing phosphorus, and anaerobic phase is provided, this polyphosphate comes out of the microorganism, and the concentration of phosphorus increases. This is in anaerobic phase. Say for example, 4 hours anaerobic phase, all the phosphate that is present in the microorganisms comes out into the liquid phase, that is wastewater. In the subsequent, after 4 hours of anaerobic phase, another 4 hours of aerobic phase will be provided. In that phase, this released phosphorus and raw wastewater phosphorus will be taken inside the microorganisms called as phosphorus accumulating organism. It will release in anaerobic phase and take up in aerobic phase. But while taking up, the raw wastewater phosphorus will also be taken inside, you can see. And the polyphosphate concentration within the microorganism will increase. After aerobic phase, after 4 hours of aeration, the aeration will be stopped, and these microorganisms will settle to the bottom, and it will be taken out. This microorganisms, phosphorus accumulating organisms, contain phosphorus, and it can be used as fertilizers for plantation growth. This is the mechanism of enhanced biological phosphorus removal, and I have done some studies on this. I will not go into much detail. One cycle I will show you. See, phosphorus concentration. The left graph, right graph, you can see in the anaerobic phase, the concentration is increasing because the release from phosphorus accumulating organism occurs. After that, including wastewater phosphorus and released phosphorus will be taken up in the aerobic phase. So from 4.5, it is increased to 9 milligram per liter, 9 or 10 milligram per liter due to release, and the entire 10 milligram per liter of phosphorus will be taken up in the aerobic phase. This is called as enhanced biological phosphorus removal, and this is my research project, and I have done this study here also. You can see in the graph, phosphorus release occurring in the anaerobic phase. In the aerobic phase, the entire phosphorus is taken up. And this microorganisms involved in phosphorus uptake from wastewater, I have isolated, I have enriched it, isolated, and under scanning electron microscope I have observed it. And this is the organism. You can see this is called as Arthrobacter species, and you can see the size of the micrograph. It is 5 micrograph and 20 micrometers. 20 micrometers and 5 micrometers. The size, you can see the scale, and you can imagine the size of the microorganism. And within this microorganism, the release of phosphorus and uptake of phosphorus takes place, individual strain. You can imagine this is another scanning electron micrograph taken, that is phosphorus accumulating organism, that is Arthrobacter species. Another is Lampropedia species. This is also a phosphorus accumulating organism I have isolated. Pseudomonas species, you can see the strain, and 10 micrometer is the size. You can see the scale and you can observe what is the dia of the organism or size of the organism. Then Streptomyces clavigerus is another phosphorus accumulating organism. So with nutrient removal and organic carbon removal, the wastewater will be further treated in activated carbon filter, wherein odor and color removal takes place from activated carbon, that is by adsorption. And further it is sent to pressure sand filter. Pressure sand filter, again filtration takes place to remove solids, any remaining solids, and disinfected. So with this treatment scheme, by removing organic carbon, nutrients, color, odor, and solids, and by killing the microorganisms, we can reuse the wastewater for construction purpose. One example is concrete I am giving, and concrete is the most widely used material worldwide, and concrete industries have the environmental and societal responsibility to contribute to sustainable development of the countries, and it is a significant contributor to air pollution because we use cement here and coarse aggregates and fine aggregates, which contributes to air pollution like particulates, and also a consumer of vast quantities of natural materials, including water. This is very, very important, water. Concrete is one of the largest water consuming in construction industries. Concrete is one of the largest water consuming item in construction industry, and approximately 150 liters of water is required per cubic meter of concrete mixture, without considering other applications of water at the concrete industry. Say for example, other applications include washing of coarse aggregate or curing, whatever it might be. So this 150 liters per cubic meter of concrete mixture is almost equivalent to 1 person drinking water needs per day. It is the standard is 135 liters per capita per day drinking water requirement per person in Indian cities. It is almost equivalent to that. And the principal consideration is on the quality of mixing water, and that relates to performance of concrete. So quality of the water plays an important role in the preparation of concrete. And normally in our department, we have laboratory facility, water quality testing facility. Many builders will bring their water samples, especially CPWD works, Central Public Work Department works, wherein it is compulsory to test the water which is used for construction purpose. and we test in our laboratory and we give the report. So impurities and chemical constituents present in water actively participate in the chemical reactions and thus affect the setting time, the hardening of the concrete, and strength development as well as durability of the concrete. So very important is impurities and chemical constituents. In addition to that, the workers will be exposed to such water. Okay, so health issues will be there. So the workers directly they will be touching the water, and we should take care of such health issues. That is, safe handling of such water should be considered in the site. There are limits are specified for mixing water with their constituents such as total alkalis, chloride, sulfate. I'll show, and whatever the treatment I have told, that is biological treatment and disinfection, ensures safety in handling of reclaimed water. And the reclaimed water, groundwater, treated water from sewer, and water from ready-mix concrete plant that is used for concrete making. And in regions like Qatar and Dubai, where you'll not find much water, drinking water available, they cannot afford for construction purposes, and they are moving towards identifying new sources of water, including treated wastewater for construction activities. And in these countries, treated wastewater are being used for irrigation purpose as well as concrete mixing, curing, and washing of aggregates. And there are several research carried out in the world, and with the various levels of success, the treated wastewater can be used in concrete preparation. Okay. The recycled water consists primarily of mixture of water, cement, and fines that remain after removal of aggregate. And it also includes the wash water used for washing and cleaning, and the trucks, whatever it might be, and concrete pumps, mixer washing. So these are all can be treated as wastewater from construction activities. Concrete made with recycled water are durable and exhibit the similar properties as concretes made with drinking water or fresh water. I will show you one research outcome wherein the regular drinking water has been used and recycled water has been used for concrete, and cube testing has been done. The results I will show you. So in Indonesia also, researchers have shown that concrete with improved initial compressive strength could be made with reclaimed wastewater, partially or totally in lieu of the mixing water. In Saudi Arabia, I said already, in Arab countries they are using treated water for construction activities. In Malaysia also, they are using treated effluent for concrete mixing, and their result showed that treated effluent increases the compressive strength and setting time when compared with potable water, and it is almost comparable. But what are the tests to be done for the reclaimed water or treated wastewater that should be used for concrete or any construction activity? One is pH, limits of acidity and alkalinity test, solids concentration, chlorides, suspended matter, sulfates, inorganic solids, and organic solids. These are some of the parameters that are considered, and generally quality of water same as drinking water for construction purpose, but the limits provided for all this parameters should be checked, and it should be comparable with drinking water. So there is, you can see, if the quality of water to be used for mixing is in doubt, say for example, if we are using reclaimed water or treated wastewater for construction purpose, what we can do is we can make cubes of 75 in cement mortar 1:3 mix, one with distilled water, one with treated wastewater, one with distilled water, the other with treated wastewater in 1:3 cm, and they are kept for 7 days strength, and the cubes should attain 90% of the 7 day strength obtained in cubes with the same quantity of distilled water. So it should be comparable. If it is comparable, then we can say the treated wastewater can be used for construction activities. And these are the limits given by IS code 3025 for water quality for construction purpose, concrete construction. Organic solid should be less than 200 milligram per liter. Inorganic solids less than 3000 milligram per liter. Sulfates 400 milligram per liter. Suspended matter 2000 milligram per liter. Chlorides, it is for concrete 2000 milligram per liter without steel, and with steel, that is for RCC, it is 500 milligram per liter chlorides, because salt content will be there and it might corrode the steel. That is the reason they have limited to 500 milligram per liter. Whenever we use the treated wastewater for construction activities, health assessment of workers is very important, because they will be exposed to such water. So Environmental Protection Agency in 2004, that is US EPA, for making concrete, they suggested wastewater treatment unit process, that is secondary treatment with disinfection, what we discussed earlier. And the BOD 5, organic matter should be less than or equal to 30, solids will be less than or equal to 30, fecal coliform less than or equal to 200 colony forming unit per 100 ml, and total residual chlorine, it should be less than 1 milligram per liter. So if the worker is exposed to such water, then it has to be disinfected further, and the colony, the fecal coliform should be less than 14 colony forming units per 100 ml of wastewater. This is what I said. This is done in India only. Cubes, conventional concrete cubes and secondary treated wastewater cubes. Cylinders as well as cubes have been compared, and it is almost comparable. The compressive strength 7 days and 14 days, it is almost comparable. In fact, compressive strength is more in secondary treated wastewater cubes and cylinders. Just another 5 minutes, I'll tell you some examples. Sunil, can I take another 5-10 minutes?
Yes, sir.
Yeah.
Yes.
I was State Environmental Appraisal Committee member for 2 terms, and it is constituted by Ministry of Environment and Forest, Government of India. And basically environmental clearance will be given for infrastructure projects, mining, whatever it might be, developmental activities. And there we evaluate environmental impact assessment. Say, for example, if it is a construction project at Mangalore, from Mangalore also, many construction project EIA report has been prepared, and they have taken the environmental clearance from the authorities. In such reports, what they do is, under construction phase and under operation phase. Operation means once it is handed over to whoever buys the properties, okay? Once it is handed over, in both the phases, how the impact will be there, that will be shown in EIA report. Just an example of Bangalore, water for construction activities will be sourced from external suppliers, and wherever there is no water available, PWSSB water is available, they will source from external suppliers, or they will buy the wastewater from STPs of BWSSB. Normally, no wastewater generation will be there from construction activities. This is one project at Bangalore, wherein domestic wastewater to a tune of 28.5 cubic meter per day of wastewater will be generated from workers, construction activity only. During construction phase, around 28.5 cubic meter per day of wastewater will be generated. And what they do with the wastewater is, either they will treat it in on-site mobile sewage treatment plant. In Bangalore, you will see mobile STPs for construction. For construction place only, they will take the STP, and whatever the wastewater generated, they will treat it in the STP. Or in tankers, the workers generated wastewater will be sent to BWSSB sewage treatment plant for further treatment. This is construction activity. And water requirement for construction purpose, you can see the quantity of work, concrete curing, it is 64,000 meter cube, and rate of water usage is 0.9 meter cube per meter cube. For the entire construction activity, for concrete curing only, they need 57,000 meter cube of water. So totally, say for example, floor finishing, sprinkling for dust suppression, roof work, totally is around 60,000 meter cube of water is required for construction purpose. And for drinking water needs, it is 36,000. That is labor drinking water need. And the construction period is 72 months. And the wastewater generated is average 30 KLD per day. This is the water requirement for construction purpose. So total water requirement for operation phase, operation is once the project is completed and it is handed over, is 672 KLD. And this 672 KLD will be treated in their premises, the STP sewage treatment plant. And normally they propose MBR or sequencing batch reactor. And that treated wastewater will be used for toilet flushing and other uses like gardening, landscaping, then vehicle washing, whatever it might be. And around 227 KLD is used for toilet flushing. In Bangalore, all the apartments and commercial complexes are provided with the dual plumbing system. That is two pipe system, one for drinking water, the other one for treated wastewater. Treated wastewater will be carried in other plumbing line for toilet flushing and other activities. So this is water balance chart for that apartment, and fresh water requirement is 275 kiloliters per day, and flushing water is 227 KLD, and for other purpose like gardening or washing vehicles, it is 170. So total demand is 672 KLD. Out of that, 95% will be generated, converted to wastewater, around 638, and 638 KLD STP will be provided. Whatever the treated wastewater will be used for landscaping inside their premises, 46 KLD, car and other vehicle cleaning purpose, 31 KLD, and common area, floor washing purpose, 9 KLD, and excess water to avenue plantation and construction work. You can see construction, they will sell the wastewater for other builders. This treated wastewater, they will sell it to or give it to other builders for construction activity. This is the flow scheme. And SBR, I was telling, I told you anaerobic aerobic phase. First is bar screen, equalization tank. This is biological reactor, and decant tank. This is a batch reactor, and whatever the sludge produced, which is rich in phosphate, will be used as manure. And the biologically treated water is taken for pressure sand filter and activated carbon filter, wherein solids, color, and odor will be removed. And chlorine is used for disinfection. Once it is disinfected, it will be taken out and it is used for various secondary purpose. This is the sewage treatment plant that is provided. Almost all apartments are buildings at Bangalore. And this is the water breakup at 670 KLD. Residential units, I said 135 liters per capita per day. For clubhouse, it is 15 liters per capita per day. And the flushing water requirement, it is 45 liters per capita per day. It is like that. Okay. So they will show the water breakup, and total water required is 672 KLD, and 672 KLD STP will be used. Okay, this is sustainable development. I will skip this. Final is NE water. It is also called as new water in Singapore. And if you Google it, you will find this information. And just to brief about this, in Singapore, the availability of space is like it is very less, and water requirement is also more. Okay, so what they are doing is they are reclaiming water from wastewater generated from Singapore. They are also buying the water from Malaysia, raw water as well as wastewater from Malaysia, and they have made an agreement till 2061. They will give that such water. They are buying the wastewater and raw water from Malaysia and treating in Singapore, and the treated water is ultra clean and it is safe to drink. Wastewater generated from Singapore, from Malaysia, raw water from Singapore and Malaysia, they are taking it and treating at one place at 4 treatment units, and they are treating to such extent it is ultra clean and safe to drink. An international group of experts in engineering, biomedical sciences, chemistry, and water technology, they have made research from NE water quality, and they said it is meeting the requirements of drinking water. So with the 5 million people in the year 2014 living in Singapore, so NE water supplies are transferring wastewater to qualities better than what we get in our tap. See, what we get in our tap is treated water. From a river, water will be taken, it will be treated. But in Singapore, wastewater is treated and they are maintaining the minerals in water. That is very important. In recycled water, they are maintaining the mineral, what we call it as mineral water, bottled water in India. That by wastewater they are getting it, and 4 purification plants are there and producing 430 million liters per day of new water. Okay, and it is given to industry and cooling facilities as well as for drinking water requirement. And this is the STP sewage treatment plant at NE Water, Singapore. Further, they are providing microfiltration, RO unit, and ultrafiltration, and the final water is supplied as drinking water for industries and other secondary purpose. And these are the bottles you can see. Singapore World Water Day 2013, any water, any new water. Okay, this water, bottled water, is nothing but treated wastewater and water. It is mixed. Okay, mixing, and they are treating it to such a level it is come down to mineral water and drinkable water. So these are some of the standards and codes for that is testing of water for concrete or mixed concrete, structural concrete. You can look into these codes. And finally, closing the loop, we have source to tap. Source to tap is, in the beginning I showed river examples where we are polluting the rivers. From that source, we are taking it to tap as a drinking water management. But in our houses, we convert that precious water to wastewater, and we are sending it to same source, rivers. But that should not happen. That should not happen, and we have to go for wastewater management. We should avoid discharging wastewater to our rivers. That is this year theme, World Environmental Day. It is ecological restoration. We have to prevent such activities. How we can prevent is we can use such wastewater, treated wastewater, for other secondary purposes. We need to tackle pollutants at their source, not at the end of municipal effluent pipe. And we need to invest our efforts wisely where the benefit to cost ratio is clear and positive. And best example is like mega cities like Singapore, wherein the wastewater is converted to crystal clear water, that what we drink. When they are converting it, at least what we can do is we can treat the wastewater and use it for other secondary purpose. It might not be for drinking water, we can use it for secondary purposes. This is near Kudremukh. There is a dam called Lakya Dam, and that industry has been closed and irreparable damage has been done. Now nothing, this dam is of no use. It is full of ore containing waste. And this is again some of the rivers where we are monitoring for its quality. And you can see aquatic species, fishes in the river where there is no wastewater. Whenever there is wastewater entry into rivers, this will migrate or it will die off. This is again Kali River. This is what ecological restoration I said in the beginning, this World Environmental Day theme. We can restore our rivers. We should allow the aquatic species, flora, fauna to be there in that environment. How we can do is we have to treat the wastewater, and we should not let the wastewater into the surface water bodies such as rivers. So this is my presentation. If you need any clarification, we can get the clarification. Sunil, I'll stop at this stage.
Yes, sir.
Yeah. I hope 10 minutes more I took it. Sorry,
Yeah, no problem,
sorry for that.
No problem, sir. No.
Thank you, sir, for your wonderful presentation.
Thank you.
With
Thank you.
Mangalore as one of the smart city for our students who are working here on the project, it was a nice input to them.
Yeah.
Sir, I have one doubt.
Yeah, sure.
Sir, now the students, when they started the project, it was fine. But once the lockdown happened, they could not do any experiments and all. Maybe in environmental projects, many, and even in concrete also. Now, in that case, whether they can model that in softwares and get the results?
That is difficult, but what they can do is they can do some literature survey. Say, for example, I was telling about wastewater utility in concrete preparation and all.
Yeah.
Such things they can review the literature. There are many literatures available in and it is in peer-reviewed journals. They can do that and they can look into it. But if they want to do experiments, it should be done in the laboratory only. So first-hand information is always better.
Okay, sir.
Say, for example, say I was telling about river water quality. That can be
Yeah.
done theoretically. Modeling, there are many mathematical models available.
Yeah.
Say there is a river flowing behind your institute, no?
Yes, sir.
Sahyadri College, Netravati.
Netravati.
What they can do is they can do modeling. Mathematical models are available. They can predict the water quality. If there are any wastewater entry into that river, they can find it out. Maybe small villages and all on the bank of the river, they will be discharging the waste into the river. They can do such modeling work. And another thing is, it is estuarine part before entering into the sea. Okay.
Yeah.
Salinity intrusion they can see, because such waters cannot be directly used for concrete purpose.
Yes, sir.
Because salinity will be more, salt content will be more.
Yeah.
So what is the salinity? It should be less than 5 ppt. So
Yes.
they can do such modeling, mathematical modeling, salinity intrusion, how much from sea it has entered to river water, and at what places the water is more than 5 ppt salinity. They can do such experiments theoretically.
Okay, sir. Yes, sir. Now already one project is going on, and our Department of Civil Engineering under guidance of Hemant Prabhu sir, it is happening. And one of the project where they are constructing a dam to stop the entry of salinity towards this side, so that they can use the water.
That is what I said. Modeling.
Yeah.
They can do the mathematical modeling.
Yes, sir.
That is in Tumbe, no? Tumbe.
Not Tumbe, sir. Near our college only, just to
Okay.
next to college in Adyar.
Okay. Okay. What they can do is there are models, mathematical models. Salinity intrusion in different seasons they can predict. Summer ಅಲ್ಲಿ ಎಷ್ಟು intrude ಆಗುತ್ತೆ, rainy season ಅಲ್ಲಿ ಎಷ್ಟು intrude. They can do such
Okay, sir.
work.
Fine, sir.
Okay.
Hemant, sir, can we end the session? Hemant, sir.
So I come to the end of this particular program. Vote of thanks. First of all, I thank our Dr. K. Prakash, Chairman. Am I audible?
Yes, sir. You're audible, sir. Now.
Dr. K. Prakash, Chairman, IC Mangaluru Center, who is present here and made this function a very grand success. I once again thank Dr. K. Prakash on the behalf of myself and ICI Mangaluru Center and all the faculty of Sahyadri College of Engineering and Management. Thank you, sir.
So thanks for the organizers for giving me an opportunity to present my views in this webinar. Thank you.
Sir, thank you, Manoj sir, for your beautiful presentation. It was a nice presentation with all the inputs what the students will get for their, it will help them for their projects as well. So thank you from Sahyadri College of Engineering and Management as well as from Indian Concrete Institute, Mangalore. Thank you, sir.
Thank you. Shall I close it?
Yes, sir.
Thank you. Thanks a lot.
Thank you, sir. Yes. Thank you, Hemant Prabhu, sir. Thank you, sir.